Hi all, this is Santiago Garay, and I'd like to show you a little bit about this new version of SkinDesigner that we just updated and uploaded in the Food for Rhino website, version 0.50. This version has a very specific new feature which is called surface panel mode, and I wanted to do this tutorial to so you at least understand what are the capabilities of this new mode, and how you go about with a workflow that would work for this new feature, and a few specific parameters that were added in this new version for the surface panel mode. So I'm going to describe a little bit what I have here. On the side of the panel, configurations are very simple. Nothing really changed, or very little things have changed from the previous version. The only thing you see here, a panel with a clad surface and a window. There's a new parameter on the window, which is the conformed surface panel, and I'll explain that later. But also you have dimensions here that we normally specify. We don't have to do that anymore if we don't want to. The only reason why these dimensions are is in case we want to visualize this panel with a specific size, but otherwise this will go with some default size, and it will not count much on the solution if you're in the surface panel mode, since it will basically use the surface to dictate the panel size and shape. All right, so and this shape is just a solid panel at this point, in this panel specifically. So we have a window and a solid panel, and we'll play with that a little bit to show you the different things. We have some new parameters, as I was saying, that I will explain as we develop the skins and the solutions. And then I have, for this test, a surface that is a freeform, typical freeform surface that have double curvature and all these things that you will understand how will behave SkinDesigner trying to panelize that. I'm using in this example some component from the Launchbox plugin to give you a range of panel shapes that you could use for this SkinDesigner. You don't have to use Launchbox. You can use any script that you have for that. But this is a typical a range of different panel shapes that you could use for with SkinDesigner. So I think with that, I think we can just start rendering or generating a solution with this same configuration. I'll take a while because as I run this, I'll explain a little bit that now there are as many panels created as specific shapes of specific dimensions of these shapes are being plugged in. So what I didn't specify here is that, first of all, I have a setting that makes this even faster. I will explain that later. But I will run, we'll generate the surface again. And you'll see it take a little longer now, since again there's around maybe 400 panels or actually more than 1,000 panels in this solution, and each panel has unique dimensions. There you go. So also I plugged in here a panel inventory, so you see the panels are being created. There are total, actually 456 panels. That was right at the beginning, and that many panel types created. So again, there's that kind of limitation, or I guess it's a thing to keep an eye on as you play with this surface, that you have to optimize your project. I imagine, unless you want to have you have an infinite budget on how many repetitive, how many unique panels you have. But for SkinDesigner, it's good to show you that you will create whatever surface or surfaces you provide, and it's a matter of how complex are your panels and how long will take, and as well as a file size and things like that. But to activate surface panel mode, first of all, it's the new setting on this drop down that I provided here in Skin. If I go down to SkinDesigner, you'll see on this list here the skin parameters, and the surface panel mode has to be turned on, otherwise it will go and we'll do the previous version of SkinDesigner, which is trying to create up, straight up panels of these panels. Will create like rectangular versions of them and vertical ones. So you need to make sure that is specified to understand that these are unique surfaces that you want to create a panel for with each of them. Now, I'm gonna show you different options here, but I'm gonna do a Boolean just to limit our number of surfaces to only a portion of this and make it faster, more iterative as I explain different things. I'm just gonna run how you can quickly create different shapes, with the different options of Lunchbox in this case. Also, triangular panels can be, adapted to, these panels, even though they are have 4 sides, you can adapt it to these panels, and depending on your dimensions of your windows and other properties, they may adjust, better or worse than what you expect sometimes. But in this case, you'll see that there's a condition here, and that's why I like to show this, that it's not showing you the 2 panels that I plugged in here, but only the first one. So SkinDesigner, basically based on your, I'm gonna turn this off for a second, based on your on your surfaces or matrix or a group of surfaces that you're providing, is trying to understand where the rows and columns, and it definitely goes from 1 to 2nd to 1st through each surface you provide, right? So let's say, I try to get an item here and say, say something that shows me the first one, and I'm gonna click on this. You see the order that these panels were generated is going up, but they're not connected in its surfaces. So see that it's only going like up in that direction, but the fact that they are not touching themselves with any vertices, then SkinDesigner thinks that it's a new a new area, a new location of that other surfaces. So while these ones, for instance, are connected as you go up in these bands, then understands each of these is a row. So the way that you know how to specify the rows, but SkinDesigner has to do that, is detecting your how those surfaces touch with each other. So if you don't have this case, is the way this was generated by Lunchbox, is definitely not following the touching points, and that is what it's it's creating this this connection, and it was always thinks it's a new group or a new location of a surface when it's not touching. So you should have gone in the other side and the other direction to understand them as raw, right? So just something when you generate these surfaces to keep in mind. All right, so I'm gonna go ahead and link again this one option and a group of surfaces, and turn this on again. So the one thing you could also, I have to explain it here, how is the decided what is the plane. These panels are still flat panels, are planar surface, planar panels. They are not, even though the surfaces may not be planar. SkinDesigner still need planar versions of the panels to be generated. So how is that detected? And that's something you need to know probably to make sure you get the right orientation of your panels, is using the first vertices of your panel and each side out of that corner. So that's why there's a way you can control that by using this another parameter, which is a surface panel orientation on the skin parameter list. And you have another group of options here with the surface panel orientations. I just added that for you to be easier to find what are the options. But here you can rotate actually how is detected that panel as you provided. So of course everything rotates, the window rotates, so you can use that to rotate as well, the actual panel. But it also is using now a different point of your panel to dictate the orientation. Okay, so that's how you can go through all these options and find the right orientation and the way you want that panel to be oriented. All right, so that's the first parameter that I added here. The other thing that I will try to explain here with another option, say we have this configuration. Actually, my bad, this is the one I was looking for. So here you have different panels with different sizes. I wanted to have an option that I can provide areas of a threshold area that you say anything under that area or that threshold, it will not be created. Say something like 40 square feet in this case. These are really big panels, as you can imagine. So these are the areas that they are under that. So that's something I thought useful when I was dealing with things like imagine a dome where the panels can be really small. If you're doing quick surface, quick freeform panelized surfaces of a dome or something of that, a cone that has a very small panels that are being generated, you want to have a way to control which ones are ignored. Also because you may have undesired results when they're so small with this type of panel designs, right? So that gives you a very good way of filtering that. I'll leave that back to 0. Now the last thing I'm gonna just show you also a little bit of, I think this is a very useful feature when you're dealing with a lot of geometry, a lot of different unique panels, and a way to optimize your iterative design process. I'm gonna go and turn this off, or lock this and lock this for a second, connect all the panels, just show you a solution that takes very long, but I'm gonna go and connect this to this surface here that has, and explain also how SkinDesigner works with something like this that is quite different. I'm actually gonna connect a custom geometry, which makes it a lot slower because it has a lot more detail now, and a lot of booleans happening with this solution. So I'm gonna turn this on, and as there's gonna be a number of panels being created, but there's a lot of repetitive panels in this solution, in this surface. So we're gonna start seeing, how it is. SkinDesigner is reusing panels as it finds these panels with exact dimensions. And I'm selecting here these panels, and you can see how it's showing us that two blocks of the same type they're being selected, so that tells us it's reusing our panels and panel types. Okay, so the same with these objects as well, of course. So in this case, because it has a single curvature, every row has the same panels being reused, right? Every row in this direction. But say you, in this case, you still want to reduce some number of panels. Here we have 74 panels created, but say we want to specify a number here that will make that being reduced. And what is that panel profile tolerance, which is what I'm trying to explain here, is basically SkinDesigner has a database and it's creates these panel types, storing them in there, and each new panel comes in and you look at the dimensions and check on the database and see, okay, how are we already created a panel with exact dimensions. Now this new parameter allows you to be a little more flexible about what is called a good match for that dimensions, right? And basically it's saying that every corner now within an inch would be acceptable as a appropriate panel. So by having that 1 inch parameter value, we reduce that panel types to 20 now. And you probably don't see that 1 inch difference. Is very subtle. In some cases, you won't be definitely visible, but in some of these maybe they are. Now, if we go ahead and we specify now half a foot, that is can be accepted is within that distance. Now you see those panels are more obvious here. I see the overlapping between these two, for instance, that are probably under those 6 inches, right? So what it does, in a way, this allows you to play with, just to change the shape of your surface or even the layout of the panels. Those are still pretty clear, and they are acceptable as solutions for that. And at the same time, you're speeding up your solution, and the file size gets reduced. So this is something that is very useful, in cases that there are a lot of geometry, a lot of different panel types. But if we push this, now we can, for instance, go ahead and go back to our initial surface. Something that the other surface has so many unique panels that will take a long time, at least 2-3 minutes to generate those many unique panels. So in this case, we are being able, in this case, to speed up that process, and we'll see how long it takes. Well, so it finished after 85 seconds. So we can, now when this viewport updates, now we can at least have this solution being generated in a decent amount of time compared with the the version with all these unique panels. Of course, with 6 inches, you see probably those areas where they're not an exact match, and the point again is not to be precise in this stage. It's more of a draft version, but it's actually not as simplified, because it's actually creating 2/3 at least of the number of the total panels. So what if we move this to a foot? This threshold to a foot probably will be a big change there. We'll see. So, well, we reduced that to 43 seconds. And again, you'll see the bigger gaps now between those panels, but the idea is that you can have this rough version that you start visualizing a little bit the overall look of your panels and your layout as you play with these shapes. So that's kind of the main explanation of this new property, a new parameter. I think it's going to be handy, especially when we're trying, we're using all these different panel shapes. Here we see as well how these can really be reused. Again, you can really go all the way to something, that it will use very few panels. And again, it will be a good way of saying, okay, I got understanding my layouts are correct, my overall shape, and that's it. But of course, you see how ugly it gets when you're trying to use only few panels, like in this case 14 panels for a lot of different type of shapes, so with very different dimensions and shapes. So again, this is very useful, I guess, for that type of thing, but it's not to be considered as a precise or accurate solution at this point. Another thing I forgot to mention, and I think I can add this right now. I'm gonna turn this off for a sec. Go back to our settings. It was about that window conform to surface parameter on the window component, and I would show you this option. I think it's a good one for that. And I turn this on. So once we have this generated, we're going to explain a little bit. There you go. So as you see, the windows are, even though we are specifying here the dimensions, and these dimensions are based on the window height and the window width. So that's why always the dimensions of the windows change. But also the fact that these windows are being generated parallel to the size of the surface, it's a new parameter that we're specifying here. So I'm gonna turn this off so you see the difference. But still, even though the surfaces are of this irregular shape, the windows are trying to be, by default, are trying to be with parallel sides. So once we refresh, you'll see, there you go. So it will respect the dimensions, but it will stay on the parallel side. So it's using a conformed rectangle inside this surface to define the surface size, and then from there it's using these parameters. So if you have also absolute dimensions here, these will be absolute dimensions of your window. So that's to know how much you want to be a precise dimension window. But most of the cases, I guess, the conformed surface is the way to go. So especially when using those panels that have mostly glass, right? So that is something that you have to specify and turn on to get the effect like these ones we're seeing here. So that's actually all it is at this point on the this part of the tutorial. And the first tutorial then would be probably another one that has to do with how to use with surface panel mold your layer control is what I call now in this new version, and the panel controller, and understand there's some new things there now that available to us with using these surfaces as inputs. All right, see you on the next one.